Hello everyone, welcome back to another session of Science by Asha Matpal. In today's session, I will be continuing with the class 10 CBSE board syllabus. I was teaching you chemical reactions and equations, and in that chapter we have already understood till combination reaction and decomposition reaction. Today I will be explaining displacement reaction and double displacement reaction. But before I move ahead in my session, I would like to request you all to kindly subscribe to my YouTube channel and share its link among your friends and family. So let's begin today's session. Now, we have understood that what are chemical reactions and what are chemical equations. How we can write a correct chemical equation that you can write with the help of the valency and with the help of the atomicity. In my previous session, I have already given you a valency chart and an atomicity chart which will help you in writing the correct chemical equation. Now we will start off with today's topic, that is the displacement reaction. If you see, the literal meaning of the word displacement is to displace anything simply. Okay. Now let us consider an example, a reaction where A reacts with B, C. BC is a compound. Okay. Now in the product we are getting AC plus B. A plus BC is the reactant side, right? It is the reactant side. AC plus B is the product side. Now, if you observe this reaction carefully, you can say easily that A has pushed B out from the compound BC. Okay, it has pushed B out. Right, and A has combined itself with C, and that is why it is forming compound AC, and B is left alone here in the product. Right, so this is a very general equation for the displacement reaction here. Okay, now what happens in the displacement reaction is this, that generally a more powerful, or you can say in chemistry language, more reactive element displaces, more reactive element displaces the, it will displace least reactive element, least reactive element from its salt solution. Okay, meaning to say that, like in our everyday life, what we observe that if there is a fight between a very weak person and a very strong person, then what happens? Mostly the strong person whose build is more strong is able to win over to a very weak person whose build is very much weak. Okay, so the same thing is happening here also. When there is a presence of a more reactive element, then that reactive element with its power pushes the weak element from its salt solution. The same reaction I will be explaining you again here. The general reaction here, A is a metal, right? It reacts with BC. BC is in aqueous state. Aqueous meaning to say that it is it gets dissolved in water. Aqueous means what? It gets dissolved in water. Dissolved in water. So BC is mixed with water. BC is mixed with water. Okay. Now in this BC solution, if you will put A and if you will mix it, then what will happen? A is a more reactive metal. We are considering here that it is a more reactive metal as compared to B. As compared to B. B here is a metal. Okay. Now what will happen? When A is mixed with BC, the solution of BC, then A is more powerful, it is more reactive. So it will do what? It will displace this BC, or it will push out BC simply from its salt solution, and it will form compound with C. So the product will be AC and BC will lie alone. Right, so this is a displacement reaction, or this is the concept basically, or the basic principle behind a displacement reaction. Now we will see examples, some examples, but before going ahead we will be trying to understand the definition of the displacement reaction. Now, reactions in which a more reactive, here, more reactive element displaces a less reactive element from its compound are called as the displacement reactions, right? And they are generally found to occur in solution, okay? They are generally found to occur in solution. Now, how we are going to decide that whether this is more reactive or it is less reactive? Now, all the metals and the non-metals are arranged in order of their reactivity, and that is called as the reactivity series, right? Now, here I am showing you the reactivity series of metals where few selective ones are kept. This is not the full list of the metals. Remember, we are only dealing with the metals which are important to you in terms of the class 10th point of view. Okay, so here you can see that there is a activity series or a reactivity series where elements are arranged in order of their reactivity. If you observe here, you will be seeing that potassium is the highly reactive metal here, followed by sodium, then calcium, magnesium, aluminium, zinc, iron, lead. Okay, reactivity gets decreased as we move from top to bottom. So potassium is highly reactive and the least reactive is gold. Below gold we also write platinum sometimes, okay, and this is hydrogen which is here. Okay, so this is the reactivity series or the activity series. Generally it is defined as when metals are arranged in a vertical column in order of their decreasing reactivity. That is called as activity series or reactivity series. Okay, now the same thing is mentioned here also, that arrangement of metals in a vertical column in order of their decreasing reactivity from top to bottom is called as activity or reactivity series. So we will keep this in mind whenever we are writing a displacement reaction. In a displacement reaction, always the highly reactive metal will displace a less reactive metal. For example, if you are seeing that sodium is getting combined with the salt solution of the copper or the mercury or the silver or a gold, sodium will definitely replace the copper, mercury, silver, gold from their salt solutions. Okay, right? Now we will be moving ahead and we will be seeing some common reactions here for the displacement. Now see, when iron combines with copper sulfate, that is when you draw few nails of the iron in the copper sulfate solution, the copper sulfate solution is blue in color. Okay, and if you will shake it, you will keep it for some time. After some time, you will be seeing that the solution of the copper sulfate, which is blue in color, has turned into green. Okay, light green color will start coming. Okay, meaning to say that iron, which is more reactive as compared to the copper, okay, iron will displace, it will push copper out, it will push the copper out from its salt solution and it will form its own compound. Fe will combine with SO4. Okay, Fe will combine with SO4, and how you are going to write or how you are going to form this compound, again you will be using valency here. Iron valency is 2 and SO4 valency is 2. This 2 will go to Fe and this 2 will go to SO4, so the compound will be SO4. When valencies are same, they are never shown. So FeSO4 will be formed and copper will be out Okay, so this is an example of a displacement reaction where iron, which is more reactive, has displaced copper. It is more reactive. It has displaced copper, which is less reactive from its salt solution. Okay, now going to the next reaction, if you will drop few pieces of the zinc in the copper sulfate solution, what will happen? Zinc is more reactive. It is more reactive as compared to the copper, so it will do what? Zinc will push copper out and it will form compound with SO4. So again, how you will form compound? For that you will be using the valency Zn SO4. Okay, Zn valency is 2 here, SO4 is also 2, so this 2 will go to Zn and this 2 will go to SO4. It will form ZnSO4 and copper will come out. Now copper plus AgNO3. Okay, now copper is more reactive as compared to the silver, so it will put the silver out. So it will form compound with NO3, CuNO3. Now what will be the correct compound? CuNO3. Okay, copper valency is 2, NO3 valency is 1. This 1 will go to Cu, this 2 will go to NO3. So the compound will be CuNO3 whole twice. This 2 will go to NO3. So you will be putting a bracket and you will be writing 2. So it will be CuNO3 whole twice plus Ag. Okay, how you can balance it? Simply write 2 here in front of Ag. This 2 will be going to Ag. So here you can write 2 here. So it is 2 Ag. NO3 is 2. Here also NO3 is 2. Okay. Now next reaction, Pb plus CuCl2. Here you can see that Pb is more reactive as compared to the copper. So it will put the copper out from its salt solution. It will form compound with Cl and copper will come out. Now what will be the correct compound? Pb and Cl here. Pb valency is 2 and Cl valency is 1. This 1 will go to Pb, this 2 will go to Cl. So the compound will be PbCl2. Okay, so it will be PbCl2. Okay, so in this way the displacement reaction occur. They are very simple. You will have to just keep in mind the reactivity series or the activity series and you will be able to write it correctly. Now what will happen if you take a less reactive element? Okay, for example, if you see the reactivity series, you can see that the silver is less reactive as compared to the copper. Okay, so if you will be putting the silver in the copper, then what will happen? For example, if Ag plus CuSO4 is there, then such kind of reaction will not occur because silver is weak. It is weak, so it cannot displace copper. It cannot displace copper from its salt solution. So this reaction will not occur simply. Okay, so it is always the high reactive metal or the most active metal will be able to displace the less reactive metal from its salt solution. So here silver is weak as compared to the copper. So silver cannot push out copper from its salt solution. Copper sulfate is more powerful over to Ag. Okay, so there will be no reaction. There will be no reaction here. Now let us see that what is the application of this displacement reaction. The displacement reaction are mostly used in the extraction of silver and gold. Okay, when they are taken out and when they are purified, there also we see that it is done using a displacement reaction. There are certain few more points that displacement reactions are always exothermic in nature. That is, it releases energy. It releases energy, right? And in the displacement reaction, it is always between one element replaced by another one element from its compound. For example, we have seen that iron is dropped in copper sulfate. So here one element is there which is displacing another element from its salt solution. So they are also called as a single displacement reaction. That is, there is only like this reaction is occurring where only one is displacing another element simply. So they are also called as a single displacement reaction, but the more popular name is simply the displacement reaction. Now let us understand that what are double displacement reactions. Now the word is double, that is, we are seeing that displacement will occur twice. Okay, and rather we will not say displacement here. What we see, that there is an exchange. There is an exchange. For example, let us say that AB reacts with CD. Okay, and it forms compound AD plus CB. Now what is happening here? This is the reactant side, right? This is the reactant side and this is the product side here. Now you are seeing that AB is getting combined with D and BC is getting combined together, right? So there is exchange between two different atoms or between two groups of atoms basically. Okay, so there is an exchange here in this reaction, exchange which is occurring between two different atoms, or group of atoms, right? If we will observe further, they always occur in the ionic compounds and there is an exchange of the ions in this one. Okay, there is an exchange of the ions and thus how it is called as a double displacement reaction, because it is occurring twice. Like A is forming with D and B is joining with C. So there is exchange of ions. Or you can say that the displacement is occurring twice. It will become more clear with the help of the example we will be seeing. Now, first of all, we'll see the definition of double displacement reaction. Reactions in which two different atoms or group of atoms are exchanged are called as double displacement reaction, or they are also defined as reaction in which ionic compounds in their solution react by exchanging of their ions to form new compounds are called as double displacement reactions. Okay, now I'll show you some examples for it. The double displacement reaction, for example, the barium chloride reacts with sodium sulfate. Now if you observe this compound barium chloride, barium is a positively charged ion and Cl is a negative charged ion. Similarly, Na is positive and SO4 is negative. So what is happening here, that this is also an ionic compound, this is also an ionic compound. So when two ionic compound reacts in their solution, like when BaCl2 is mixed with water and Na2SO4 is mixed with water, and when both are combined together, then this reaction will occur. Where we will be seeing, you know that opposite charges attract. So what will happen? Ba will combine with SO4, right? Ba will combine with SO4 and Cl2, which is negatively charged, it will combine with Na, which is positive charge, and they will form a compound. Now the valency of Ba, barium, is 2 and SO4 valency is also 2 here. Just a minute, let me get this pen here. Okay, so barium valency is 2, SO4 is also 2, so this 2 will go to barium, this 2 will go to SO4. So when valencies are same, they are never shown, so they will form BaSO4. Now Na valency is 1, Cl valency is 1, this one will go to Na, this one will go to Cl, it will form NaCl. So thus how the compound BaSO4 and NaCl will be formed. And here we are seeing that there is exchange of ions between the ionic compound. Okay, so that is why it is called as double displacement. Once Ba is getting combined with SO4, second Na is combining with Cl. So there is a double exchange. So what we are saying it as double displacement reaction. In the double displacement reaction, the products which are formed, they are generally a precipitate or a gas is also sometimes formed. Precipitate are what? They are the solid which look like the curdling or the curd pieces which are hanging there in the solution, and later on they settle down. So here what we see that BaSO4 will be a precipitate. Either we write PPT or we write a downward arrow showing that they will get settled at the bottom. Now similarly, AgNO3 and NaCl, they both are ionic compound, and Ag is positive, NO3 is negative, NaCl is positive, Cl is minus. So Ag will combine with Cl here, okay, and NO3 will combine with Na. So Na will combine with NO3 and they will form compound. For writing the correct formula, again you will be using the valency. Ag valency is 1, Cl valency is 1. They will go to their neighbors, so the compound form will be AgCl. Na valency is 1, NO3 valency is also 1, so they will also go to their neighbors, and 1 or when they are same, they are never shown, so it will be NaNO3. And same thing I have written here, AgCl and NO3 will be the formed compounds in the product, and AgCl will be a precipitate. This is also white in color. Okay, a precipitate of AgCl will be there and a solution of NaNO3 will be there inside the test tube. Now we can see a few more reactions of the double displacement. FeS, that is the ferrous sulfide, reacts with H2SO4. Now here we will be seeing that this is the positive, this is negative, this is positive, this is negative. So Fe will combine with SO4 and S will combine with H2. So the formed compound will be FeSO4 plus H2S, which is a gas. This is a gas. So FeSO4 will be formed. It is in the, you can say, the aqueous state will be there. Then we are having AlCl3 plus NH4OH. Al, which is positive, Cl is minus, NO4 is positive, OH is minus. So Al will combine with OH with opposite charge ion, and Cl will combine with NH4. Now you can see Al will combine with OH. Al valency is 3 and OH valency is 1. This 1 will go to Al, this 3 will go to OH. So what will be the compound? Al, OH thrice. So Al, OH thrice will be formed. It is a precipitate, that is aluminium hydroxide will be formed, plus we are having NH4 and Cl will combine together. So its valency is 1 and Cl valency is also 1. So this one will go to NH4, this one will go to Cl. So the compound will be NH4Cl. So NH4Cl will be the another compound. It will be in the solution state, that is in the aqueous state. Now how you will be balancing it? OH is 3 here, so just write 3 in front of the NH4 OH. So OH will become 3, OH is 3 here. NH4Cl, you write 3 here, so NH4 will also become 3 and Cl will also become 3, like Cl3, sorry, here, and here also Cl will be 3. So this is about the double displacement reaction. Now with this I am finishing today's session. Keep practicing them. For writing the correct compound or the correct equation, you need valency and the atomicity. In my previous session I have given you a full chart of the atomicity and valency, which are important for the class 10 purpose. Go and watch my previous videos, you will find them. If you have any doubt, you can write in the comment section. I will always give answers to those questions, remember. And before signing off, I would like to request you all to kindly subscribe to my channel and keep watching this space for more sessions. In my next session I will be teaching you ahead in the chapter. Thank you. Bye bye.